Hey everyone, Mr. Fransky here. I had a request to do some of the homework problems from 2.5. This is just the 6 problems, 27 and then 33 through 36 and 49. So I'm going to run through all of them. Hopefully it's useful for you, and let's see if we can figure some stuff out. So polynomial, factors, zeros, x-intercepts, complex roots, stuff we've been talking about. So find all zeros and write a linear factorization of the function. So I have a cubic here, so I can't just straight up factor it. I can't use quadratic formula, so I have to think about what my tools are here. They don't give me any zeros, so I can't divide yet. So I have to go straight to the rational root theorem. So rational root theorem says I'm going to have factors of 5, which are plus and minus 1, or plus and minus 5, divided by factors of the leading coefficient, which is 1. So that's just plus and minus 1. So the possible roots I could have, plus and minus 1, plus and minus 5. Those are my only choices. So let's start with positive 1, and hopefully we'll get lucky. So coefficients here, 1. Ooh, I'm missing an x squared term, so I have a 0. And then I have a 4 and a negative 5. Let's see if 1 works. 1 comes down, times 1 is 1, plus 0 is 1, times 1 is 1 again, plus 4 is 5. Hey, look at that. 5 makes a 0. So what I've shown now is that f of x, I found a 0, right? I found a 0 is 1, and my factor that goes along with it, x minus 1. So I know that f of x is x minus 1. Now where's my quotient? What's the result in here? Ah, that's right. Synthetic gives it to me here. So it's x squared plus x plus 5. Then some people ask, well, how do you know that it's x squared plus x plus 5? How do you know the degree? Because the last one's always the constant. So I just add up. So this is a constant. This must be the linear term in x. This is our quadratic term, x squared. So now we have to be able to find the last two roots out of here. I can't factor this. So I have to use quadratic formula. So this is going to give me two roots, negative b, plus or minus, so let's do negative b plus square root b squared minus 4ac over 2a. And the other one's going to be negative b minus square root b squared minus 4ac over 2a. So this will be a negative 1 plus square root of b squared is 1 minus 4ac is minus 20 over 2a is 2. And this guy is going to give me a negative 1 minus square root 1 minus 20 over 2. Both of these are going to have some i's, right? This is square root of negative 19. Square root of negative 19 is I times the square root of 19. So this is negative 1 plus I root 19 over 2. And this is negative 1 minus I root 19 over 2. So I'm just going to leave them like that. They're pretty gross, but it'll work. So f of x is x minus 1 times x minus negative 1 plus I root 19 over 2. And x minus negative 1 minus I root 19 over 2. Now you might say that's pretty gross. I agree, but who cares, right? It's just do the math, put in your answers. So to finish my zeros list here, I can write them over here maybe. My zeros that I have are 1. That one was easy to find. And then I have negative 1 plus I root 19 over 2. And negative 1 minus I root 19 over 2. And that's my list of zeros. So I have my zeros and I have my linear factorization right here. Cool. Linear means no squares, right? X plus, x minus. That's all we have. Let's try the next one. So, given the 0, find all zeros and write a linear factorization of f of x. So, let's make a list of zeros and factors. So my zeros here, 1 plus I. If 1 plus I is a root, we know we must have 1 minus I because the conjugate root's there. So factors, x minus 1 plus I, x minus 1 minus I. All right. So, we know right now that this is equal to, so f of x we know, whoops, I don't know why it's written up there. So we know f of x equals x minus 1 plus I times x minus 1 minus I. Now I'm missing some more factors, right? How many am I missing? I'm looking for a quartic. I must be missing 2 more factors. I don't know what they are. So how do we undo multiplication? How do I figure out what this is? Well, I'm going to divide this. So I'm going to divide, excuse me, I'm going to divide f of x by these 2 factors. And in order to do that, I have 2 choices. One is I could do these one at a time. I could divide by the zeros one at a time, right? I could do 1 plus I, put it into the box, do the synthetic, and then do 1 minus I. Got to deal with a lot of i's there. So what I'm going to do here is actually do long division. I'm going to multiply these together first, and then I'm going to do long division. So I multiply these 2 together. So right now I know f of x is equal to, this gives me x squared. Then I have minus x times 1 plus I, and then minus x times 1 minus I. Sorry, I should do this in the order I want to. So the outside terms give me minus x times 1 minus I, and then the inside terms give me minus x times 1 plus I. And then I have plus the product of these two guys, and they're conjugates. So I just use a squared plus b squared. That's 1 squared plus 1 squared, which is 2. Okay, so here I have minus 1x plus an xi minus x minus xi. Those xi's will cancel. So we have x squared minus 2x and then plus 2. So that is going to be divided, right? So I know that f of x is equal to all of this times I don't know what, and this is times I don't know what. Okay, so I'm going to divide f of x by x squared minus 2x plus 2, and that'll give me that question mark. So let's do that over here. So I'm going to do x squared minus 2x plus 2 into x to the 4th minus, let's put a 0x squared there. Oh, nope, sorry. Look at the wrong thing. Minus 2x cubed minus x squared plus 6x minus 6. So x squared into x to the 4th, that needs an x squared. Multiply down gives me an x to the 4th, excuse me. X to the 4th minus 2x cubed. 2x cubed, yep. And then plus 2x squared. So subtract that. This cancels. These also actually cancel. That's nice. Negative x squared minus 2 more x squared is negative 3x squared plus 6x minus 6. So x squared into negative 3x squared, that makes a negative 3. I put that on the constant because we got rid of those third degree terms, so we don't have to have a quadratic at all. Sorry, we don't have to have a linear in our answer. So now if we multiply, hopefully everything's going to go away. So we have negative 3x squared. And then we have plus 6x minus 6. Yay, that makes 0. Okay, so this question mark I now know. It's x squared minus 3. I know how to factor that, right? So at this moment, I'm going to go back to our factors. We have x minus 1 plus I times x minus 1 minus I times x squared minus 3. X squared minus 3 is kind of weird. We can actually factor that as a difference of squares. It's weird because 3 is not a perfect square, but we can just use square roots. So this is x minus 1 plus I times x minus 1 minus I times x plus root 3 times x minus root 3. So there's our linear factorization, and my last two zeros, if I put them on this list, are root 3 and negative root 3. So we have all of our zeros, and then I have my last two factors listed here. I don't have them listed on my list, though. Nice. All right, here, 4i is a 0 of this guy. So we're going to do the same thing here. We're looking for those factors. This time, because it's just 4i, so let's make a list of our zeros and our factors. So 0 is 4i. That means that's 0 plus 4i, right? 4i is really 0 plus 4i. So then 0 minus 4i is also going to be a root. Factors x minus 4i, x plus 4i, right? Because you subtract it, right? So right now I know f of x is equal to x minus 4i, x plus 4i, times something. I don't know what that something is. I have to divide. Once again, I could multiply and do long division. We did that last time. This one, since it's just 4i, I think it's going to be easy to do synthetic. So let's put 4i into the box. We'll do this one first. You can do the negative one first as well. Coefficients, we have some missing, so I have to be careful here. 1, 0, 13, 0, negative 48. Line down here. 1 comes down, times 4i is 4i, plus 0 is still 4i. 4i times 4i is 16i squared. That makes a negative 16. Plus 13 is a negative 3. Multiply by 4i gives me a negative 12i. Add 0 makes me a negative 12i. This is a really nice one for synthetic. Wow. Negative 12i times 4i, that is a negative 48i squared. I squared is negative 1, so that makes a positive 48, which gives me 0, which we expect because they told us it's a 0. Now, so what I know is I have the x minus 4i. This right down here, these coefficients are the coefficients of the question mark and the x plus 4i. I can still take the x plus 4i out. So what I'm going to do now is just put the negative 4i to line it up right underneath. Line down here, 1 comes down, negative 4i. This should all end up with real coefficients. That makes a 0. Makes a 0 here, makes a negative 3. Times negative 4i is positive 12i. That cancels. There we go. We don't use the remainder, right? We only use the coefficients we're left with. So right now what I know is f of x is equal to my first factor, x minus 4i, times my factor I just divided by, x plus 4i. And I'm left with this, x squared minus 3. Hey, we've had that before, right? That happened on the last problem. So I can actually add this to my list. I'm going to find those last two factors. It's just x minus 4i, x plus 4i, and then x plus root 3, x minus root 3. So I can add those to my list. I have root 3 and negative root 3, and those give me the factors x minus root 3, x plus root 3. So here are all my zeros, and here is my linear factorization. All right, moving on. 3 minus 2i is a 0 of this hunker. Okay, so let's make a list of our zeros and factors. So zeros right now, I have 3 minus 2i and 3 plus 2i, right, because of conjugate roots theorem. So that gives me x minus 3 minus 2i, x minus 3 plus 2i. All right, so I need to know what I have left, right? So I have f of x is equal to those two factors, x minus 3 minus 2i times x minus 3 plus 2i times who knows what. So we're going to have to find that question mark, so we're going to divide. Once again, I'm going to multiply them first, right? Because I like to do that. It gives me an easier way to use all real numbers. So if we multiply these, I'm going to do this a little faster than the last time. X squared. I'll have a minus 3x and minus another 3x. That's minus 6x. I know the xi's are going to cancel, right? We have a negative 2xi and a positive 2xi. They're going to go away. Now I multiply these conjugates. 3 squared is 9. 2 squared is 4. 9 plus 4, 13. Okay, that was a little quick, but a plus bi, a minus bi, those are conjugates. Remember, when we multiply them, it'll always just be a squared plus b squared. And since they're both negative, it's going to give me a positive 13. So it's that times my question mark. So I have to figure out what that is. So I'm going to put x squared, let's do it over here, minus 6x plus 13 into x to the fourth, see that? Minus 6x cubed plus 11x squared, plus 12x minus 26. All right, x squared and x to the fourth, that's an x squared. Multiply down, x to the fourth minus 6x cubed. That'll go away again, that's nice. And then plus 13x squared. Cancels, because we're subtracting, right? 11 minus 13 is a negative 2x squared. Plus 12x minus 26 comes along for the ride. So I need a negative 2. Oh, these all end up being nice little kind of difference of squares things. Okay, so multiply down gives us a negative 2x squared plus 12x minus 26. Yay, everything goes away. Okay, so that question mark I now know. That question mark is x squared minus 2. Because when you multiply x squared minus 2 by 6x, or x squared minus 6x plus 13, you get our quartic. So I can now factor that, right? We know this is x minus 3 minus 2i, because we just expanded it out. X minus 3 plus 2i times x plus root 2, x minus root 2. Okay, so we add those root 2, negative root 2. There are zeros. Here is our factorization. We can add the factories to our list too. X minus root 2, x plus root 2. There we go. Moving right along. 1 plus 3i is a 0 of this quartic. All right? So maybe this one will do synthetic on. It's a little bit messy, but we'll give it a shot. So we know that our zeros, 1 plus 3i, 1 minus 3i. So our factors that we have so far are x minus 1 plus 3i and x minus 1 minus 3i. Looking for 2 more. So I'm going to do synthetic this time. So let's try this one with synthetic. So we put 1 plus 3i into the box. Coefficients here, 1, negative 2, 5, 10, negative 50. And you'll see the synthetic with the imaginary is a little bit tricky, but it's not too bad. So 1 comes down, times 1 plus 3i is 1 plus 3i. Negative 2 and 1 are negative 1 plus 3i. And this is where it gets tricky. We have to multiply these. So we have 1 plus 3i times negative 1 plus 3i. It gives me negative 1. Plus 3i minus 3i. That's nice. The i's go away. And then 3i times 3i is 9i squared, which is minus 9. So it gives us a negative 10. Plus 5 is negative 5. Times 1 plus 3i is negative 5 minus 15i. And 10 give me 5 minus 15i. I have to multiply over here. So we have 5 minus 15i times 1 plus 3i. Gives me 5 plus 15i minus 15i. That's nice. And then minus 45i squared, which is a plus 45. Okay, so the i's go away, which is good. And then 5 plus 45 is 50. Hey. All right, so a little bit of extra algebra we had to do over here, but nothing impossible. So I've taken out the 1 plus 3i. Now we do the 1 minus 3i. Now hopefully this is going to give me real coefficients. It should. Uh-oh. No, go back. Go away. Don't want you. There we go. Okay. So 1 minus 3i should get us all real coefficients again. So let's see here. The 1 comes down, times 1 minus 3i is 1 minus 3i. Hey, the i's cancel, and so do the 1's. We have 0. Times 1 plus 3i is 0, negative 5. Times 1 minus 3i is a negative 5 plus 15i. Nice, they go away. All these problems work out so nice. This is great. So now I know that f of x is our two factors. No, go back. Our two factors. Oh, come on. 1x minus 1 plus 3i times x minus 1 minus 3i times x squared minus 5. Okay, so x squared minus 5, I don't know why it keeps jumping. X squared minus 5 is x plus root 5, x minus root 5. Those factorings kept being so nice. X plus root 5, x minus root 5. Cool. Okay, so I have my last two zeros, root 5 and negative root 5. And my factors that go along with them, x plus root 5. Let's get rid of these. X minus root 5. I guess I mixed those up. This should be the minus, this should be the plus. Nice. Okay, got our factorization down here. Zeros up here. All right, last one. This is really more what we're doing on 2.5a, but let's do it anyway. So we're looking for the unique polynomial with real coefficients that meets these conditions. So we have zeros at 3. That means we need an x minus 3. Negative 1. That means we need an x plus 1. And 2 minus I. That is x minus 2 minus I. Now, they say real coefficients, which means we must have 2 plus I as well then. So we have x minus 2 plus I. They tell us we want f of 0 to be 30. So let's plug in 0 here. So we plug in 0 in all these x's. We're going to have a negative 3 times 1 times 2, negative 2 minus I times negative 2 plus I. So let's see here. This gives us a negative 3 times, these two negatives are going to cancel out to positives. 2 plus I, 2 minus I. 2 times 2 is 4. So 2 squared plus 1 squared is 5. Right? Conjugates, a squared plus b squared. That gives me a negative 15. I want it to be a positive 30. So how do I do that? I just throw in front negative 2. Because now, when I plug in 0, I get negative 30, but we still have all the same roots. That's all there is to it. So there you go. Homework in under 20 minutes. Love you guys. That's why I'm here. Have a great day.